Determine all intervals of concave up or concave down and determine the coordinates of all inflection points, including cliffs, for the function f of x equals 5x squared minus 3x plus 11. The first thing to do is find the domain. F of x equals 5x squared minus 3x plus 11, which is a polynomial, and a polynomial has a domain that is all real numbers, or negative infinity to positive infinity. The next thing to do is find all candidate numbers. We will need the second derivative. We will start with the first derivative. F prime of x equals, the first term is power rho, bring down the power, multiply with the 5, subtract 1 from it. Second term is a constant times x, derivative is the constant. Third term is a constant with no x, derivative is a 0. We can now find the second derivative. First term is a constant times x, derivative is the constant. Second term is a constant with no x, derivative is 0. We can set the numerator of the second derivative equal to 0, as well as the denominator, if there is one, equal to 0, and solve for all x's. The numerator, 10, has no x's, and it cannot equal 0. There is no candidate numbers. We can now draw a domain line, a line representing the domain. It has no left end because it begins at negative infinity, and it has no right end because it ends at positive infinity. There are no candidate numbers to break the domain interval up into separate intervals. We can now pick a test value somewhere on this interval of the entire domain, which is negative infinity to positive infinity. 0 is within that interval. And we can plug it into the second derivative to test the concavity. The second derivative has no x's to plug into. It's a positive 10, which means that the second derivative will stay positive 10 everywhere since there's no x's to plug it in. And a positive second derivative corresponds to concave up. Therefore, we have concave up happening over the interval that is the entire domain of negative infinity to positive infinity. And since we had no candidate numbers, we have no inflection points. And the concavity will stay the same throughout the entire domain.